In this tutorial, we are going to talk about dimension analysis. So I've got a number of questions with me here. So the first question is saying the distance of Lusaka to Kaula Livingston is 474 kilometers. Find the distance in the units of meters and centimeters. Okay? So what we should know is that in 1 kilometer we have 1000 meters. Okay, at the same time what we should know is that in 1 meter we have 100 centimeters. Now using these values I can be able to convert 474 kilometers to meters, then from meters now I can go to centimeters. Okay, so now we are going to be using the concept of dimension analysis to convert this. What I mean here is this: I'm going to write 474 kilometer here, then I'm going to say times. I'm going to set the units in a such a way that they should cancel each other. So I know that in 1 kilometer there is 1000 meters. So I'll say in 1 kilometer, in 1 km, I've got how many meters? I've got 1000 meters. Meaning that my kilometer and kilometer can cancel. Okay? Then I need just to say 474 times 1000. I'm going to get, I just add these three zeros, meaning now this is not in meters. So I've converted 474 kilometers to meters. Okay, now I want to convert this 474 kilometers to centimeters. If I want, I can just convert these meters to centimeters. It's the same thing. So I'll say in uh, I'll say this figure in meters times, I'll set the units in a such a way that they should cancel each other. In 1 meter, how many centimeters do we have? We've got 100 centimeters. Meter and meter will cancel. I do times, I'll end up having this. I just add the two zeros. Okay? So it's 400 and C is how many zeros do we have? We've got 1, 2, 3, 4, 5, 6, 7. So this is 4,740,000. No, this is 47,400,000. So it's 47 million, let me just write it, 47,400,000 centimeters. That would be now the distance in kilometers. Then this one is, this is 474,000 meters. So we have converted now from kilometers to meters, at the same time from kilometers to centimeters. But again, you can come direct from kilometers to centimeters. Let me show you. This is what you're going to do. Okay, I'm going to write the 474 kilometers. Okay, so what I'm going to do now is I'm going to set the unit in such a way that they should cancel each other. I will first convert this to meters, meaning in 1 km, in 1 kilometer I have got 1000 meters. Again, I'll say in 1 meter I've got 100 centimeters. What does it mean? Km and km will go, meter and meter will go, meaning I have got 474 times 1000 times 100. I'm still getting the same one. 47,400,000 centimeters. As simple as that. So that is it for question 1. Now I've got question 2, which is saying a packet of sugar has a mass of 500 grams. Convert the units to kilogram. So what we should know again is that in 1 kg we have got 1000 grams. Okay, therefore I can say 500 grams. I'll set the unit in a such a way that they should cancel each other. I'm going to say in 1 kg, how many grams do we have? We have got 1000 grams. So now we can clearly see that gram and gram can go. Then it is 500 divided by 1000. So I'm getting 0.5 kgs. That is it. If you want, you can use the concept which you were using when you were in secondary, where you say in 1 kg we have 1000 grams. Then x we have 500 grams. You cross multiply, you find 1000 grams times x is equal to 500 grams times kg. Now we can divide both sides by 1000 grams, even here by 1000 grams. So these will cancel, x will be equal to gram and gram will cancel, 1000 into 500, 0.5 kgs. But this method, most of the times we use it when we are dealing with maybe secondary level, but under NS, when we're talking about natural sciences, we use this dimension because this topic is under dimension analysis, so we prefer using that. Okay, so that is it for question 2. Question 3 is saying convert 8 hours to minutes. So we should know that in 1 hour we have 60 minutes. At the same time we have 60 seconds. Now let me just put it like this. Then in 1 minute we have 60 seconds. Okay, so we want to convert these to minutes. So what I'm going to do is I'll say 8 hours, set the units in such a way that they should cancel each other. So in 1 hour, how many minutes do we have? 60 minutes. Hour and hour will cancel, so we'll say 80 times 60. So I'm getting a 4800 minutes. Okay, that is it for question 3. Question 4 is saying an airplane took off from Lusaka airport to at 14 hours and arrived at Dubai airport at 20:30 hours. Calculate the duration of the journey in minutes and seconds. So this is the same concept. Question 3 we're talking about how to convert. Even here we're going to do the same. Now we need first to find the the hours which we have. So we'll say 14. Okay, if we do 20, which is 20:30, minus 14 hours. So if I do minus, I'll get 0, I'll get 3, I'll get here, I'll get 6, here 0. Meaning we have got 6 hours, 30 minutes. So it took about 6 hours, 30 minutes for this airplane to reach in Dubai. Okay, now we convert these minutes which you have, which is 30 minutes. I'll say 30 minutes times, okay, we want to convert it to hours. So we'll say in 1 hour we have got 60 minutes. So minutes and minutes will go. So we'll say 30 divided by 60, which is 0.5. So now I've got 6 hours plus the 0.5 hours. So the total time was 6.5 hours. That is the time. Now we have to convert this one to minutes. So I'll say 6.5 hours times, I'll set the units in such a way that they should cancel each other. So in 1 hour we have 60 minutes. Hour and hour will cancel, so we'll say 6.5 times 60, I'm getting 390 minutes. So it took about 390 minutes for this airplane to reach to Dubai. Now let's convert this now to seconds. If I want, I can just do direct to say 390 minutes times, in 1 minute I have 60 seconds. Then I do this times 60 again. So I'll end up having 23,400 seconds. So these are my seconds and these are my minutes. As simple as that. Okay. If I want, I can come direct. If I want, I can come direct from minutes, from hours, direct to seconds. Okay, what am I going to do now is I'll say 6.5 hours times, I have to convert these to minutes. So I'll say in 1 hour, I have 60 seconds. Again, what are we going to do? We are I have got 60 minutes, sorry. So I'll say in 1 minute, I have got again 60 seconds. So these units will cancel, these ones will cancel. So if I do times there, I'll end up having 23,400 seconds. That is it for question 4. So we have another question which is very interesting actually, which is saying Hooke's law states that the force F in a spring extended by a length x is given by F is equal to negative kx. According to Newton's second law, force is given by mass times acceleration, where m is the mass and a is the acceleration. Calculate the base unit and the dimension of the spring constant k. Okay. Now, initially, this is a very interesting topic, which is under Hooke's law. Hooke's law, you do it in second semester. Okay, which is under simple harmonic motion or mechanical properties of matter. Now, we have been given that k under Hooke's law, it obeys this formula. But according to Newton's second law, force is given by mass times acceleration. We want to find the base unit. What are base unit? Base unit, these are units which you cannot add any units to make that to be 1. Okay, what I mean is I can give an example of Newton. Newton is not a basic unit, it's a derived one, because Newton is coming from as a result of mass and acceleration. So this is a basic one. But when we're talking about the basic units, we are talking about the mass. Okay, we're talking about the length, the time. Okay, we're talking about the ampere, we're talking about the coulomb. All these, they are basic. Now, initially we are only interested, most of the times we're going to be dealing with only these under dimension analysis. We're going to be dealing with mass, length, and the time. So this is in kgs, this is in meters, this is in second. We cannot add these units is not as a result of combining two quantities. No, it's just natural, just like that. These are what we call fundamental units or basic units. Okay, now here is the issue. In this case, when we are trying to find the SI unit for k, we have to use the basic. Okay, so what are we going to do? What we're going to do now is, since you have been told that F according to Newton's second law is given by ma, I'm going to replace this with ma. Okay, so I'll say it's mass times acceleration is equal to k. Now we're talking about the units, so negative will not affect anything. I'm going to ignore negative for now. Negative kx. I'll divide both sides by x, both sides by x. These will cancel. So k will be equal to mass times a divided by x. X is distance in this case, okay, which is in meters. So it's length. Now, in this case, we are trying to find the basic units. So the basic units now is going to be like this. Mass is in kgs. Acceleration is in meter per second squared. X is in meters because it's the length. Okay. Now I can clearly see that this can be cancelled. So my k, the basic units will be kg, okay, seconds to the power negative 2, or I can just say kg per second. Okay, now in this case, what we are trying to say here is this is going to be the units for k. Okay, but sometimes you can leave it to say it's the same as just like this, or here I'm supposed to put a squared, then you put this. This can also be, you can also leave the answer there, but since you can cancel m, that's why I've just left the answer here. Sometimes you can leave this answer in form of k to be equal to kg times second to the power negative 2, meaning p has been removed. Okay, so this or that is correct. Now, what are the dimensions of k? Now, to find the dimensions, what I'm going to do is what we have to do is I'm going to say, since f is given by kx, when another f is given by ma, so I'm going to replace f with ma. Okay, so I'll say, or even here you can just say is kx is equal to ma. It's the same. We divide both sides by x, both sides by x. K will be equal to mass times acceleration divided by x. Here I'm supposed to put x, sorry. Now, the dimensions, what we normally do here is this. When we're talking about the mass, initially it is in meters. Sorry, the mass is kgs, okay? But when we're talking about the dimensions, we use the symbol capital M, now in square brackets. Acceleration, it is meters per second. So what we normally do is this. We'll say this acceleration. So now for time, let me first do for time. Time is in second, so we use capital T. Then we also have length. So for length is in meters, we know that, so it's capital L. Done. So acceleration, we know that it is in meters per second. What does it mean? We have two things. So what I'm going to do first is I'm going to say k will be equal to m, which is mass, in this case is kg. I'm going to put kg first. Mass is, or acceleration is meters per second squared. But this second squared, I'm going just to put s to the power negative 2 divided by x is also meters. Next, what I'm going to do now, I'm going to replace with the dimension. When we're talking about dimensions, we mean the square brackets. We are talking about these now. So I will replace each by what I have there. So I'm going to say my k will be equal to kg. I will replace it with a capital M. Okay, which is mass. Next, this is meters. Meters is length. So I'm going to say it's length. I put them in square brackets. Next, I have seconds, which is in t. But since it is to the power negative 2, normally here what we would normally mean is here, when we have got meters per second squared, this is the same as meters s to the power negative 2. Because this is the same as m to the power, like this, m over s squared. So if I want to remove the division, it's going to be m s to the power negative 2. It's the same. Okay? So that's what we're going to have. So I'm going to put here my t. Now since it is squared, negative squared, I divide this by, down here I've got length, but I'm supposed to do like that. Now at this point, what I'm going to do now is I can see that down on top here I've got L, down here I've got also L. What I'm going to do, I'm going to cancel this. So meaning k will be equal to the m and t now in squared. These are the dimensions of k. And remember we said that the SI units was, this was mass, which is kg. That's what we say, the base. Now it was like this. So this is that, this is that. So this is the dimension of the spring constant K. As simple as that. Okay. So now that is it for question 5. So we have another question, which is question 6, which is saying find the fundamental units and dimensions of the following. Pressure is given by the density. This is rho, which is density. Density times G times H, where P is the pressure. This is the density, acceleration due to gravity, then we have got height. Okay. Next, what we are going to do now is the question is find the fundamental units and dimensional. So now we start with pressure. What are the SI units for pressure? Okay. Or before I do that, let's first find for density. We know that density is equal to mass divided by volume. Mass is in kg, volume is in meter cubic or cubic meter. So density is kg per cubic meter. So these are the fundamental units of the density. Now we go to acceleration. Acceleration due to gravity we know already. It is just meters per second squared. Height, it is in meters. Now we can find the dimension analysis. We see what we're going to have. Pressure, initially pressure is the SI unit is Pascal. Now Pascals is the same as Newton per meter squared. Okay. So what I mean is that the fundamental units, now since this is Newton, again Newton, we know that Newton is kg from force, because we know that force is given by mass times acceleration. So since this is in kg, then this is acceleration is m per second squared. So I'm going to replace Newton now, meaning that the pressure, the SI unit for pressure is kg, okay, times meter per second squared. Now I can see that what I have now, these are fundamental units. So these are the fundamental units of pressure, height, gravity, acceleration due to gravity, then density. Now let me just rewrite them here. So I have the density, which is represented by rho. We are saying it is kg per cubic meter. Now we want to see the dimensions of each of the following. We want to see what's going to happen. So the left and the right, we need to get the same one. So now let's start. So we'll say, I'll start. Pressure is equal to the density times G times H. First, I'm going to replace with the basic, the fundamental units. Pressure, we have said that the SI unit is kg, then meter per second squared. Then the density is kg, okay, per cubic meter. Acceleration due to gravity is meters per second squared. Height is in meters. Now what we are going to do is I'm going to rearrange this. This is the same as kg times meters divided by s squared is equal to then kg, okay, divided by m to the power 3 times m, then I have got divided by s to the power 2 times again m. I can also rewrite this and say is kg meter divided by s squared. Then now meter and meter can be m squared. So I'll have kg m squared divided by m to the power 3 times s to the power 2. Now I can now go to my dimensions. Since I know that I no longer need this, I know that where there is kg, I'm supposed to replace it with the square brackets of mass. Where there is meters, the square brackets of length. where the second, the square brackets of time. Let's go ahead and see what we're going to have. So we're going to have kg is going to be replaced by meter. I put it like that. Then, which is m, sorry. Then meters is length. Then I divide this by time. Now this time is squared. I'll square it. Kg is meters, sorry, is m, capital M. Meters is length, but since it is squared, I'll square it. I divide this by, down there we have got meters, which is length. Now this length has to be to the power 3. Okay, to the power 3. Next we have got time. Okay, so time is in t, now capital letter. Okay, so now what we have there is I'm going to rearrange this from this part here. What I mean is I'm going to remove the division here, meaning I'll have m, then l. Okay, because here we had the pressure, where I said the pressure was given by is Newton per meter squared. That's what we said, right? Okay, so I think there is a mistake somewhere here. Where is it? Because pressure, this part here, pressure, since it's force divided by area, meaning it's Newton per meter squared, because pressure is force divided by area. So force is in Newton. Now Newton alone is kg. Yes, Newton alone is kg meter per second squared, but again we have got another one which is meter squared. Okay, yeah, so we have made a mistake here. I'm supposed to include the meter down here. This one is supposed to be again per m to the power 2. So meaning even that m is now down here. Okay, m to the power 2. Yes, so m to the power 2 is on top there, which is now correct. Even here I'm supposed to put m to the power 2, the one we forgot, meaning even here I'm supposed to put the k, yes, which is meters, now length, like that, now to the power 2. Okay, now it's making sense, because the left hand side and right hand side, we need to get the same dimensions. That's how it is. So what we're going to do now, I'm going to rewrite it from here. Let me just do from here because of space. I'll say m, then I've got l. Now when I remove the division, this 2 is going to have a negative, so I'll have l to the power negative 2. Again, I'll have t to the power negative 2. This has to be equal to, same here, I'll have m, I'll have l to the power 2. Now this l is going out to be negative 3. Then I have got t. Let's not forget this t was squared, so that t will be negative 2. Now I can clearly see that there are some light terms which we can add. Okay, this and that can be added. If the bases are the same, you add the powers. Here the power is just 1, so 1 minus 2 is negative 1. So I'll have l to the power negative 1, t to the power negative 2. What I have here, I need to have the same thing even to the right hand side. So this has to be equal to capital letters like the way I'm representing. So now these are the same, so I'll say 2 minus 3 is going to give me negative 1. Then t negative 2. I can see that m is to the power 1, this negative 1, even here negative 1, this negative 2, even that negative 2. So now this is the dimensions which I've gotten. As simple as that. Okay. Now, so if you read this question, it was saying, and the dimensions of each of the following. So they wanted the dimensions of each of the pressure, the dimensions of the pressure, then the dimension of density, the dimension of. But in this case, the way I've solved it, when they ask you to say is it dimensional correct, then it is dimensional correct. Now in this case, they want you to find the dimensions of pressure alone, again the dimensions of density, again the dimensions of acceleration due to gravity, using the same principle. I think you can find. Now let me just find two for you. So it is dimensional correct, like we have seen. So let's start with pressure. Okay, let me just do pressure for you. Pressure, we said it is force divided by area. Force is in Newton, this is in meter squared. Initial force is mass times acceleration. So mass is kg, acceleration is meters per second squared. We divide it by m squared. So pressure, what we had to the left hand side, this is the exact what we're going to have now. So the dimensions is going to be this kg is just m, this one is length, then now that other one is going to be time, now to the power 2. I divide it by to the power negative 2 because this is per, then length to the power 2. I can cancel one length, so I'll have this. Okay, now meaning that I have got 1, I'll remain with 1. Now that one I'm going to put it as a negative, meaning it's now on top. Then this, initially this is what we had. These are the dimensions of pressure. You go to density, same things, you just follow the same principle. So in general, this is the introduction which we have to understand under dimension analysis. Okay, so for more videos, I solved a lot of questions under dimension analysis. Just check out our videos, you'll be able to see them. I solved quite a number of questions under dimension analysis. Okay,